Hello children, welcome to 9th chemistry online classes. Chapter 4, Structure of the Atom. So in the last class we studied Bohr's model of an atom and how are electrons distributed in different orbits. Okay, so today we will study some more electronic configuration or electronic distribution in various shells or orbits. First, valency. So valency already studied in the last chapter. Valency means the combining capacity of an element. You studied like that. The definition is combining capacity of an element. Now we'll see what is that. Okay. First we have to know about valence electrons. So all of you listen carefully, okay? Valence electrons. Electrons present in the outermost orbit of an atom are called valence electrons. Example, here this is a nitrogen atom, N. N is the symbol for nitrogen. So nitrogen, the atomic number, not atomic mass, atomic number. Atomic number is the number of protons or number of electrons. And where is the location of protons? Protons is inside the nucleus. Nucleus is the center of the atom. I'm repeating this again all the classes because don't be confused, okay? So this protons are in the center, that is the nucleus, and electrons are revolving around the nucleus. So atomic number is very important, okay? So by looking the atomic number, we know the properties of that element. Okay. So atomic number is that much important. So atomic number means number of protons or number of electrons. So in an atom, protons number and electrons number are equal. Okay. So here nitrogen atom, the number of protons or number of electrons 7. So we'll just count it 1, 2. So that is the first shell, K shell. K shell, the maximum capacity is 2. And next is second shell, that is L shell, and the maximum capacity is 8. So how we can calculate that? By using the formula 2n square. So n is the number of orbits that we already discussed in the last class. Okay, so in the nitrogen, the first K shell, 2 electrons, then second shell 1, 2, 3, 4, 5. So total how many? First shell 2, second shell 5, so total 7. So that is 7. And valence electrons means the outermost orbit. This is the outermost. In the case of nitrogen, the second or L shell is the outermost orbit, and here how many are there? 5 electrons. So how many valence electrons in nitrogen? 5. Got it, children? So valence electrons means the electrons present in the outermost shell or outermost orbit of an atom. That is called valence electron. In the case of nitrogen, 5 electrons are there. So 5 is the valence electrons. Next, the atoms which have completely filled the outermost shell are not very active chemically. So we already studied some rules in that last class. And that rule, one of the rules is the outermost shell can contain maximum 8 electrons. Okay, so here in the case of nitrogen, this is the last shell. Okay, and the last shell, in all cases, all atoms, the last shell contain maximum 8 electrons. The outermost shell can contain maximum 8 electrons. So if an atom contain 8 electrons in the outermost shell or in the valence shell, that atom is stable, and that atom is not going to any chemical reactions because it's already stable, so it is not going for or it is not taking part any other chemical reactions. Example, this some exception is there, so that I will tell later. So first we will take neon. So neon atomic number is 10. So the first K shell we accommodate 2 electrons, and the second shell, that is L shell, maximum 8, and here 1 2 3 4 5 6 7 8 electrons. So 8 plus 2, 10. Okay, so that is the atomic number of neon, neon. So that is 10, and valence electrons 8. So the neon is that is an inert gas. It is not taking part any chemical reaction. Okay, but you just think about the sodium. Sodium is highly reactive, but in this neon gas is not reactive because it's valence electron, that is 8 electrons. So it will no need to take part chemical reaction because it's already stable. Got it, children? And next is argon. Argon, its atomic number is, argon is also a gas, 18. So first K shell 2, you can just count it. First K shell 2 electrons, and the second L shell, that is 1 2 3 4 5 6 7 8, and again KL M shell. So M shell, that is also 8 electrons. Okay, so 2 plus 8 plus 8, so 18, atomic number 18. And you have to see here the last shell, valence shell, it contains already 8 electrons, so it is also highly stable. Argon is also highly stable, and it is not reactive. Chemically they are inert, gas. Then here helium, but in the case of helium, atomic number is 2. So the K shell contain 2, and K shell can already, the maximum capacity is 2. So in the case of helium, 2 electrons are already there, so no need to go for any chemical reaction. So this helium is also highly stable, and this helium also not taking part chemically. Got it? So this point is important. The atoms which have completely filled the outermost shell are not very active chemically. In the case of helium, the outermost capacity is 2, that is already stable. And in the case of neon and argon, their valence electrons are 8, so they need not to take part in any chemical reaction because they are stable. The valency of an atom, or the combining capacity of an atom, is given by the number of electrons present in the outermost shell. So we already discussed about valency in the last class. So valency means you studied that the combining capacity of an atom. Combining, why the atom combine with others? For getting the stability. Okay, that is why they are taking part to the chemical reaction. If already stable atom, they will not react. Okay, so the valency means combining capacity, and how we can see the valency? By looking the number of valence electrons. Valence electrons means the number of electrons present in the outermost shell. Got it? Now we will see some examples, so it will clear to you. First we will take sodium atom. So Na. Na is the symbol for sodium. And sodium atom, the atomic number is 11. Atomic number means number of protons or electrons. Protons in the center or the nucleus, and the same number of electrons are revolving around the nucleus in different energy levels. They are called orbits, okay, or shells. So atomic number of sodium 11. So how we can arrange these electrons in that particular energy levels? So first level is K shell, K orbit. Okay, so the maximum capacity 2. So we just put 2 electrons here. And the second L. L is the maximum capacity 8 you know that 2n square, by looking the 2n square we get the maximum capacity of L 8. So 1 2 3 4 5 6 7 8 electrons we put in the second K shell also. So now total 2 8 8 to 10. Now one more is there because atomic number of sodium is 11. So one more. So the last shell 1, we put 1. Okay, now so here atomic number of sodium is 11, valence electrons, that is 1 here. Valence electron means outermost shell, so here only 1 electron. Next is, for getting stability, this sodium atom has to react with other atoms. So these electrons, the valence electrons gain or lose, then it will get stability. See, here only 1 electron, just listen carefully, okay? So last shell, that is the valence shell, only 1 valence electron. So this valence electron, the sodium atom, leave to any other or give to any other atom, it get the stability. So this is the valence electron. If this electron go to anywhere, now the atom is like that. First K shell, then second to 8 electrons. If it is 8 electrons, it get the stability. Okay, so 1 electron left means it got that charge plus, because here 11 protons, but here 10 electrons by giving the electron. You understood, children? So that is Na plus. So this sodium converted to ions. Now we will see the distribution of electrons also. In the first K shell, that is 2 electron, L shell 8 electrons, and M shell 1 electron. And in the last N shell there is no electrons, only KLM. And for getting stability, sodium atom leave this electron to any other atom. So its electronic configuration is 2 8. So this Na converted to Na plus. So this 1 leave 1. So what is the valency? Valency is 1. So for getting stability, sodium atom leave or it give or it lose 1 electron. So the valency is 1. Now we go to the next example. Magnesium. Magnesium is Mg. Magnesium Mg. Atomic number 12. Valence electrons. So first K shell 2 electrons, second L shell 8 electrons, and last shell 2 electrons. So 2 plus 8 plus 2, that is 12. Valence electrons 2. So gain or lose. So first electronic configuration also I will just tell K2L8M2. Then for getting stability, magnesium atom leave this electron and this electron, because only 2 electrons are in the outermost shell. So this leave 2 electrons and it gets the stability. So what is the valency of magnesium? 2. Got it, children? We will see the next example also. Oxygen, and it's represented by the symbol O. Atomic number of oxygen is 8. You studied atomic mass is 16, but this is atomic number of protons or number of electrons. So 8 electrons are revolving around the nucleus, 2 in the K shell and 6 are in the L shell. So gain or lose. See here 6 while looking seeing the valency, we have to see the valence electrons. So here how many valence electrons are there? 6 valence electrons. So which is easy to leave the 6 electrons to any other atom, or getting 2 or gaining 2 electrons? Gaining 2 electrons are easy for this atom, because otherwise it had this oxygen atom uh, has to leave this 6 atom to other, so that much energy it has to spend for leaving these 6 electrons. So which is easy? To get 2 electrons. Okay, so from anywhere it get 2 electrons to this outermost shell, it get 8 electrons. Okay, and that is called octet. That I will explain once more. Okay, so what is the valency of oxygen? 2. So by getting 2 electrons, it get the stability, or it get the octet. Octet means 8 electrons in the outermost shell. So all atoms are trying to get the stability by completing 8 electrons in their valence shell. So oxygen atom is always trying to get the stability by gaining 2 electrons from any other atoms. So when it gets 2 electrons, now that time 8 protons and 10 electrons. So we can the oxygen is also ion, so we can write like that, O2 minus. Okay, that you will study in next 10th standard also. I'll just tell to this. Okay, then next example, aluminium. So aluminium, the atomic number is 30. That means number of protons or number of electrons. So 13 electrons are revolving around the nucleus, 2 in the K shell and 4 are in the L shell and 3 are in the outermost shell. Here second shell, it contains 8 electrons, okay, and the third shell, it contains 3 electrons. So we have to concentrate the valence shell only. So here 3 electrons. So which is easy? Gain or lose? So it is easy to leave these 3 electrons, otherwise it has to get 5 electrons. Yes, so these 3 electrons, leaving this 3 electron is easy. So the valency is what? Valency is 3. So this aluminium changed to aluminium 3 plus iron. Okay, then next one, phosphorus. This is phosphorus P and its atomic number 15 and valence electron 5. So here 1 2 3 4 5 valence electrons. So which one is easy to complete the octet or complete 8 electrons? One way is this phosphorus atom leave 5 electrons to any other atom, or phosphorus atom has to take 3 electrons. So in this case of phosphorus, this both way they are doing for the complete the octet. So the valency of aluminium is sometime 3 and sometime 5. So sometime positive ion and sometime negative ions. Got it? So this is a complete chart. So you can see this in your textbook also, page number 51. So in the case of first one, hydrogen. So this up to 18, first 18 elements, you have to by heart their symbol, atomic number. Then neutron, okay, no problem to study because they are almost the same as the number of protons or electrons. Some variations are there, no need to study that one. But here symbol is very important, and atomic number, number of protons or electron, distribution of electrons, and valency. Okay, so hydrogen symbol is H, atomic number 1, number of protons or number of electrons also 1, and number of neutrons, no neutrons, that already we discussed, and K shell only 1. So the valency is 1, because for getting stability hydrogen atom leave 1 electron. So valency is 1. And helium, that is an inert gas, already its atomic number is 2, and 2 electrons are in their K shell, so it is already stable, so valency is 0. Next is lithium, 3, atomic number is 3. Atomic number 3 means number of protons and number of electrons are 3, but number of neutrons are 4 here. Okay, and distribution of electron 2, 1. And with this easy, 1 electron, leave 1 electron is easy to get the stability, so valency is 1. The same way you can see the 18 elements, first 18 elements. So this order also you have to by heart. Okay, children. An outermost shell which had 8 electrons was said to possess an octet. So 8 electrons in the outermost shell, valence shell, that is called octet. So all atoms are trying to attain the octet for getting the stability. So atoms would thus react so as to achieve an octet in the outermost shell. This was done by sharing, gaining, or losing electrons. So these sharing electrons that you will study in 10th standard. And the carbon and silicon, they share the electrons with other atoms. And gaining electrons or losing electron, that we already studied. And the number of electrons gained, lost, or shared so as to make the octet of electrons in the outermost shell gives us directly the combining capacity of the element, that is the valency. So by looking how many electrons share, or how many electrons gained, or how many electrons lose, that by looking that thing, by looking that number, we will get the valency of each element. Now we'll see some more examples. Fluorine. Fluorine atomic number 9. So atomic number means number of protons or number of electrons. Number of protons, they are inside the nucleus, and electrons are revolving around various energy shells. So K shell, 2 electrons, and how many left? 7 electrons. So 7 electrons are in the L shell. So in this case of fluorine, this is the outermost shell, or this is the valence shell. So here 7 electrons. So for getting the octet, or for getting the 8 electrons, fluorine atom need 1 more electron into this last, or this valence shell. So it will gain 1 electron from any other atom. So what is the valency that time? Valency is 1. So by gaining 1 electron, it get the octet. So 1 is the valency of fluorine. Next we will see silicon. Silicon atomic number 40. So 2 electrons are in the K shell, 8 electrons are in the L shell. So 8 plus 2, 10, then 4. 1, 2, 3, 4. 4 electrons are in the valence shell. So here the valency, 2 ways are actually. It can leave 4 electrons to other atom, or it can gain 4 electrons. Okay, or sharing also, that you will study in the next class, next 10th standard. So you can tell that here valency of silicon is 4. Next is sulfur. Sulfur, the atomic number is not 15, sorry, this is 16. Atomic number is 16. Atomic number of sulfur is 16. So here the first shell, K shell 2, L shell 8, so 8 plus 2 10. Then how many more? 6 electrons are in the outermost shell. 6 electrons are in the outermost shell. So for getting the stability or attaining octet, it need 2 more electrons from outside. 2 more electrons. 2 electrons. So what is the valency of sulfur? Sulfur valency is 2. Got it? Then next one, chlorine. Chlorine atomic number 17. So K shell L, 2 shell 8, and M shell, sorry, KL M shell, it is 7 electrons. First K shell, then L shell, then M shell. So M shell contain 7 electrons. So for getting octet, it need 1 more electron. So what is the valency of chlorine? 1. Okay, valency of chlorine is 1. So this is the electronic configuration or distribution of electrons in the various shells. Okay, children. So for studying this one, you have to write this thing, and you have to study by drawing these structures of, or these atomic structures, and electronic configuration also. Electronic configuration means, see, example, what is the electronic configuration of sulfur? 2. I will just show it to you. Electronic configuration of sulfur is 2, 8, 6. This is the electronic configuration of sulfur, and this is the atomic structure of sulfur. This is the electronic configuration of sulfur, and this is the atomic structure of sulfur. Okay, so all of you read the textbook and do this structure and electronic configuration of various elements. Okay, children. So thank you. All the best.